Hi, everybody. My name is Bill Troutman, and I am your math instructor. So we're in Math 1332. I'm going to cover three sections, 2.7, 3.1, 3.2. So let's just go straight into it. Let me pull it up. So in 2.7, by the way, I'm getting all these problems from the 1332 workbook. This is a workbook we issue out to our students who do the face-to-face classes, and they take notes in these workbooks while they're in class when the instructor is teaching. Unfortunately, you actually don't have an instructor that's teaching, so I'm going to be doing some of the problems, but I don't cover all of the sections. You're supposed to be doing this online, watching videos and reading the book and all that. So this is just supplemental instruction to what you should already be doing. So in section 2.7, let me make this a little bit bigger. Oh, that's the wrong thing. Give me a second. There we go. This one. There we go. It says graph the solution for the following. So we want to graph these. First, we need a graph line. Sorry, I could try to be a little bit straighter when I do this. There we go. There's my line. Here's 0. And we want to graph x is greater than 3. So 1, 2, 3. Here's 3. Graphing x is greater than 3. I'm going to put it right above the graph. X is greater than 3. So these are all the numbers greater than 3. Since we're not touched, there's no equal sign here. By the way, since this is an inequality, it says x is greater than, there's no equal with that. We put a parentheses. And it's always, the parentheses is turning towards the arrow, wherever the arrow's going. So this is the answer to problem 1. Now, problem 2 is a little different because there is an equal sign there. So if I look at problem 2, here's my number line, here's 0, here's 4. On this side is -4. This says x is greater than or equal to -4. Okay, so x is greater than or equal to. Well, greater than, this is -4. Greater than -4 is to the right. And since it has an equal sign with it, you have to put a bracket. So that's really important to know that if you have a less than or greater than symbol, you use a parentheses for them. If you have a less than or equal to or greater than or equal to, you use a bracket on the ends. So that's kind of important to know. So here, if you look, it says now we have to write the equation. This is not equal to it because it's a parentheses. And by the way, this is the number pi. So we're just going to write pi. And if you look, everything's greater. So x is greater. X is the big part. Then x is greater than pi. That's exactly how I would write it. There's no equal sign. Let's do this one. All the number line is less than -3. It's going to the left. So x is less than -3.2. Not only less than, but since it has a bracket, you have to write less than or equal to. So this is how you would write that. All right. And I'm still going. Let's see what's next. I thought I could grab this. Oh, I can't. I'm not sure how. Oh, okay. So I am on the next page. Let me go on the previous page. Was there anything? No, that was it. Okay. Okay, so we're on this page here, and we're going to graph some stuff here. Now, in the previous problem, we had x is greater than or x is less than a particular number. Well, let's draw the number line again. Here's the number line. Here's 0. Here's 7. And here's -3. Now, this is kind of important. Do you see how x is between these two numbers? And that's exactly how you should say it. X is between -3 and 7. So I'm going to draw the actual graph below this line since I ran out of room. And x is between -3 and 7. So we just write a line between -3 and 7. That's what that graph says. X is greater than -3, but it's less than 7. So x is between that's a -3 right here. X is between -3 and 7. Do you see how the 7 has an equal sign? So you have to put a bracket. But the -3 does not. So you have to put a parentheses. So this is how you would graph your solution. This is the actual answer. I want to do one of these now. This is a little different. Let me graph the line. Here's 0, here's 13, and here is 55. Now, if we read the first one, it says x, and then the arrow, x is less than 13. So to graph x is less than 13, here's 13. Less than 13 is this way. Less than is always to the left, greater than is to the right. There's no equal sign, so we put a parentheses. Then it says, or x is the big part now. X is greater than 55. So greater than 55, we start at 55 and go there. It says greater than, but also equal, so we put a bracket. So this is the graph of what they're asking for here. Less than 13 or greater than or equal to 55. Okay. All right, so let's keep on going. It says write the solution in set builder notation and interval notation. Well, this is pretty much it. These are in set builder. These are all set builder. Oh, I'm writing it white. These are all set builder notation. To be proper set builder notation, they would put an X with a line, and then they'd have this bracket, just to enclose it. But these are in pretty much set builder notation already. So now we want to write interval notation. Well, if you do interval notation is what you get when you graph it, looking at it when you graph it. So I'm going to graph this one. I'm going to graph this right here. Here's 0. X is less than -4. Here's -4.5. X is less than that. In other words, it's all the numbers to the left. There's an equal sign, so I'm going to put a bracket. So to write interval notation, first you graph it, just what I did, and then you look at the leftmost number. The leftmost number is this arrow going to the left. Well, way, that arrows keep on going. So that left number goes to -1,000, -1,000,000, -1,000,000,000,000. In other words, the leftmost number goes to, sorry, this should be a parentheses. Well, I'm not going to write anything yet. If the left number goes to -infinity, you see -1,000,000, -10,000,000. So the left number goes to infinity. The right number in this graph goes to right here, -4.5. If you look at 4.5, it has an equal sign, a bracket, so we put a bracket here. By the way, this goes to -infinity. Bracket means you're touching 4.5. You can never touch infinity, so infinities will always have a parentheses, not a bracket. So this is the answer X is less than negative 4.5. In other words, all the numbers between negative infinity and negative 4.5. This is how you would write that same answer in interval notation. So let's try this one. A is between two numbers. So if I graphed it, here's 0, here's 2, here's negative 3. A is between those two numbers. None of them have a bracket and an equal sign, so they're parentheses. That's the answer. To put it in interval notation, the left number on this graph is negative 3. The rightmost number is negative 2. And then you'd put a parentheses because there's no equal sign on it. There we go. That's the interval notation. Hopefully that helps a little. I mean, there's more we can probably do with this. So that was 2.7. But let me do one more in 2. Let me go back. I want to do one more. I want to do this one right here. Y is greater than 3.6. So if I do my number line, here's 0, here's 3.6. Y is greater than 3.6. There's no equal sign, so we use a parentheses. So the leftmost number here, if you look at the graph, the left number is 3.6. The right number way over here is positive infinity. You can never touch infinity, so you use a parentheses. We're not touching 3.6 because there's no equal sign in this. So we use a parentheses. So we use a parentheses here, and there's our answer in interval notation, 3.6 to 8. All right, so we're now in 3.1. Let's plot a couple of points. Well, this little point right here is called the origin. This graph, this is the x-axis. The x-axis. The horizontal line here, all our x numbers. By the way, this first one here is 0, 1, 2, 3, 4. On the left-hand side of 0 is negative, -1, -2. The vertical line is the y-axis. So this is the y-axis here. I shouldn't have wrote on it. I'm clear. So the horizontal line is the x-axis. This is the y-axis. This is the y-axis. And this is the x-axis. Okay. So to graph this point, you always start at 0. So we're going to graph 4, 2. By the way, all points have an x and a y. So the first part is the x. So we start at 0, 0, and then we use x4. Well, the x-axis goes right and left. The x-axis goes right or left. The y-axis goes up or down. So if x is positive 4, we're going to go 1, 2, 3, 4 spaces over. Then the y is 2. And a positive means go up. We're going to go 1, 2. So this point right here, that point is 4, 2. I'm going to erase it now and just put the point because we're just talking about this point right here. X is 4. Y is 2. So there's our point. And this point is A, 4, 2. If I try B now, start off at the origin and then go -3. 1, 2. We're going to jump 1, 2, 3. And then we're going to +1. Remember, for the x values, going to the right is positive. Going to the left is negative. For the y values, going up is positive. Going down is negative. So we have a y value of +1, so we go up 1 from here, and there's our point. That's B. D, now let's do D, +2, 1, 2, and -3, 1, 2, 3. So this is point D. So do you see how that's working? Give me a second. Hang on, let me hit pause. Okay, so the next part, down here, we want to put the coordinates of each of these. Don't forget, each of these has an X and a Y. So if I look at A, to get to this point, the start of the origin right here, to get to that point, I got to do X. I'm going to go positive 2 over positive 2. Then I'm going to go positive 6. Do you see? I go 1, 2, 3, 4, 5, 6. So A is at 2, 6. Let's do H. H, if you start at the origin, to get to H, you always go X direction first, right or left. X direction is 4, and then we go down to 5. So for H, the X direction is 4, and then we're going down to 5, negative 5. Y down is a negative direction, and so H is 4, negative 5. One more. Let's do C. C, if you start at the origin, we go 1, 2, 3 in the X direction, which is a negative 3 going to the left. And then we're going down 1, 2, which is also a negative direction. So C is negative 3, 2. All right. Identify the intercepts and graph the equations. Okay, so we have a little information that we need here. Intercepts are where there's two intercepts we have. We have the X-intercept and we have the Y-intercept. So to find the X-intercept, make Y equal to 0. So here's, by the way, I'm going to go ahead and do example 4 so I can write up here. So to find the X-intercept, make Y equal 0. To find the Y-intercept, make X equal to 0. And I'll show you what I mean here. So we're going to do the X-intercept first here. And X-intercept says make Y equal to 0. So I'm going to rewrite the equation, 3X plus 2. Oh, make Y equal to 0. So I'm going to put 0 in for Y equals 6. Well, 2 times 0 is 0. So I get 3X plus 0, which is just 3X, equals 6. Now I have to get the 3 to the other side. So I'm going to divide by 3, divide by 3. 3 divided by 3 is 1x, and 6 divided by 3 is 2. So when I made y equal to 0, by the way, here's my point, y equal to 0, my x equals 2. So you see, so this is the x-intercept. In other words, 2, 0. This is where the line crosses the x-axis. So now I have to find the y-intercept. Y-intercept is when you make x equal to 0. So look at the equation and make x equal to 0. 3 times 0 plus 2 times y equals 6. 3 times 0 is 0, so I'm just left with 2y equals 6. I want to divide both sides by 2. And y equals 3. So in this problem, when x is 0, we made x 0, y equals 3. So the question is, if we start at the origin, x direction, right or left, 0, y equals 3 right here. And there's our line. These are the two intercepts. This is the x-intercept because we made y equal to 0. This is the x-intercept, and this one here is a y-intercept because we made x equal to 0. We plot those 2 points, and then we connect the dots. That's how you do the intercepts. Just make x equal to 0, solve for y, and then make y equal 0 and solve for x. Identify the intercepts and graph. Let's try it. Let's try this number 6. So we're going to do y-intercept first. y-intercept make x equal to 0. So 3 times 0 minus 7y equals 7. 3 times 0 is 0. So I have negative 7y equals 7. I'm going to divide both sides by negative 7, divide by negative 7, divide by negative 7. And I get y equals 7 divided by a negative 7 is a negative 1. So I made x equal to 0, and my y ended up equaling negative 1. X 0, y negative 1. You see, that's a coordinate right there. That's a y-intercept. That's where the graph crosses the y-axis. Don't look at this. We're going to keep on going. Now I'm going to do the x-intercept for this problem. X-intercept make y equal to 0. I'm still on this. So I have 3 times x minus 7 times y, make it 0. Well, 7 times 0 is 0. So I'm left with 3x equals 7. Divide both sides by 3. And I get x equals, don't put a decimal, the answer is 7 over 3. So when y is 0, x is 7 over 3. Y is 0, x, by the way, 7 over 3 is like 2 and 1/3. So when x is 7, 2 and 1/3, 1, 2 and 1/3, y is 0. So that's about right there. And then you can connect the dots. And there's your line. There's your two intercepts. This is, once again, this is the y-intercept. This is the x-intercept. X-intercept, you always have y equals 0. Y-intercept, you always have x equals 0. Okay, so there are different forms of equations that we have. This equation is in the form slope-intercept. In other words, slope-intercept equation is y equals mx plus b, where if y is by itself, then the number in front of the x is the slope. And then the number, this b, this number by itself, that's b, that's the y-intercept. So the question is, identify the intercepts. Well, the y-intercept is 1. There's the y-intercept where the graph crosses the y at the x and the y-axis at 1. Now, if I want to write the coordinate for the y-intercept, don't forget y-intercept, x always equals 0. And in this case, since it's in slope-intercept form, if y by itself, then the number next to x is a slope, and the number by itself is a y-intercept. So it says identify the intercepts and graph. Well, there's the intercept. Now I need to find the x-intercept. Okay, that's going to be a little harder. Let me x-intercept. Make y equal to 0. So here's the equation again. I'm going to make y equal to 0, then 2/3 x plus 1. Well, I want to get everything to one side and make x equal, so I'm going to take the 1 to the other side. It's a plus 1, so I'm going to minus 1. I get negative 1 equals 2/3 x. I want to get rid of the 2/3 and take it to the other side. The way to do that is multiply by its reciprocal. So I'm going to multiply it by 3 over 2. So I multiply this side by 3 over 2. Do you see how the 3's cancel and the 2's cancel and you're just left with 1x? And then 3 over 2 times a negative 1. Positive times a negative is a negative, and 3 over 2 times 1 is 3 over 2. So the x-intercept is negative 3 over 2, y 0. Remember, x-intercepts, y is always 0. Y-intercept, x is always 0. So negative 3 over 2, that's negative 1.5. This is the x-intercept. And then if you connect those two dots, there's your line. So pretty much anytime you have it like, or this is not true, you have to have it y equals mx plus b. So if you don't have it yx plus mx plus b, just make x equal to 0. That's your y-intercept. Then make y equal to 0. That's your x-intercept. So it looks like, let me see where we're at here. Let me see this page. Give me a second. So we still have a couple of pages here, I guess. Those are the regular. Oh, then we have to do the ratios. So let's do the ratio part. I'm in the workbook, and I'm just going to do some extra ratio stuff. Write the ratio of 11 to 16. There's 3 ways you can write a ratio. One is a fraction, 11 to 16. Since they both have the same units, you can write a fraction. You can also write 11 with this little colon mark to 16. And then you can do 11 to 16. So those are different ways of writing ratio. Write the rear axle ratio of a car if the ring drive gear has 48 teeth and the pinion gear has 42 teeth. First of all, I don't know what you're talking about, pinion gear, but we can write the ratio. Write the rear axle ratio of a car if the ring gear has 42 teeth. So it's just 42 over 12, right? I mean, whatever the first one is goes on top, and the second one goes on the bottom. 42 over 12. Reduce the fraction. They both divide by 6. 42 divided by 6 is 7, and 12 divided by 6 is 2. So this is the ratio. And don't forget, it's just, if it's a fraction, you want to reduce it. So there's the answer. All right, what else do we have here? Find the heights. Find the following right triangles. Write the ratio of. Give me a second. I can't see it. For the following right triangles, write the ratio of the height to the length of the base. Okay. So height to the length. In other words, height is first. This is my height. If I do this one, this is my height, 12. And then to the length of the base is 5. 12 over 5. Don't forget, you can write it like this too, 12 to 5. So for this one, the height, once again, is 12. And the length, the base, is 12. 12 divided by 12 is just 1 over 1. So keep all ratios in a fraction. 1 over 1 equals 1, but we want to keep it in the fraction so we know it's a ratio. We want to calculate the pitch of the following roofs. By the way, pitch is just another word for slope. Pitch is just another word for slope. So remember, slope is the change. There's different ways of writing it. The change in y divided by the change in x. Some people call it rise over run. And rise is going up or down. Up is positive, down is negative. Run is going right or left. To the right is positive, and to the left is negative. So if I want to, I'm going to do this one. Calculate the pitch. How much does it rise? Well, it rise. This is the pitch of the roof, the slope of the roof. Well, it rises 20. The top part is it rises 20, and from here it runs 15. So this is the roof. From here to here it rises 20, and then it runs 15. So they both divide by 5. So 20 divided by 5 is 4. 15 divided by 5 is 3. So the answer is 4/3. I'm going to do one of these. I'll do this one. Give me a second. For a wheelchair ramp to be ADA, disability compliant, the ratio of the rise and run has to be greater than 1 to 12. It has to be greater than 1 to 12. In other words, the slope has to be less than or equal to 1/12. So let's take a look at this one. In order for you to do this, though, I'm dealing with feet and inches. They both have to be the same units. So it's hard to change 6.9 inches to feet. So it's easy to change 6.5 feet to inches. And there are 12 inches in 1 foot. So if I multiply this by 12, it'll tell me how many inches I have. So I have 6.5 times 12. I have 78 inches. And I have 6.9 inches here. So once again, this wheelchair, we want to know if this ramp is good or not. And don't forget, rise over run. Well, the rise from here to here is 6.9. And the run, we said, from there to there is 78. Let's put that in our calculator. 6.9 divided by 78. And I'm going to put this, I put it in my calculator. I get 0.08846. So this is what I get on my calculator. It says the rise or run is the requirement is 1/12. So this is the requirement. Let's put 1/12 in our calculator. 1 divided by 12. 1 divided by 12 is 0.0833. So the slope, my slope, has to be less than this one. If it's not, then it's too steep for a wheelchair to get up. So this is the minimum, this is the maximum requirement. This is the maximum the slope can be, 0.0833. Mine is 0.088. So yeah, this 0.0833, and this is the 1/12, and mine is 0.088. Do you see how the first two digits are the same, but the third digit, mine is greater than theirs? Our slope cannot be greater than theirs because then it's too hard to get up. The slope must be less. So this is not compliant. It's not ADA compliant. Okay, that's a cool question. Write each rate in simplest forms. By the way, a rate is always the money divided by the number of items. This is the rate. So always put money on top, or we're always going to put that's for unit rate. Well, I think we might have that later on. Yeah, here, unit rate. Always put money on top if you have the choice. If not, we're always going to put on top what they have first. So this is 186. the rate is 186 divided by 18. So I'm going to put that straight into my calculator. 186 divided by 18. And I get, so my rate is 10.33. And you see how the dollars was on top? Dollars. And then the picture frames were on the bottom per picture frame. Per picture. You see, it's $10.33 for each picture frame. You put the units on top and bottom depending on where you're at. So let's look at this one. 56 pizzas. 56 pizzas for 168 people. So we just put that in our calculator. 56 divided by 168. I get 0.33 pizzas for every person. You see, pizzas are on top. Pizza is on top and people are on the bottom. So in other words, everybody gets about a third of a pizza. If something costs $3.36 for 16 ounces, just put that straight into your calculator and it'll tell you how much 1 ounce is. 3.36 divided by 16. And it's 21 cents per ounce because we had ounces on the bottom. All right. And okay, here, let's do that number 13, and this will be our last one. A machine produces 12 pins in 40 seconds. Another machine produces 43 pins in 150 seconds. It says which one is faster? Which one is faster? Well, let's do 12 divided by 40. The answer is 0.3 pins every second, right? The pins on top, seconds on the bottom. This one is 43 divided by 150, which is 0.286 pins every second. So which one is faster? Which one is faster? Which was the largest number of pins per second? 0.3 is larger than 0.2. So this is the fastest one. This is the larger one. So that's it. That's 2.7, 3.1, and 3.2. If anybody has any questions, feel free to email me or call me. Make sure you stay current with your homework. Make sure you're looking in the weekly in Canvas. Go to each week to make sure you're doing any quiz that's due. Call me once again if you have questions or email me. Hope these videos are helping. You guys have a good week.